Hello everybody, welcome to my presentation. I would like to start with a few questions. It's not a quiz, don't worry about it. So how many of you want to be a power engineer after graduation? Wow, a lot. Me too. Have you ever heard of a device that operates to disconnect a circuit when a short circuit happens? Yes, circuit breaker. Every house has a circuit breaker. Now imagine a power station. It deals with thousands of units of voltages and current. A power station needs a complex unit for control and safety, which includes circuit breaker with other protective equipment. And that unit is called switchgears, which is my today's topic, the Willy Wonka of power system. Hi, I'm Junnat, a first year ECET student. Before going to the outline of my presentation, I would like to say a few things about choosing this topic. Before coming to Canada, I used to work in Dhaka as a power engineer in a power distribution company. As a student, I always hated power courses. But when I started working in a power system, I fell in love with it. Like when I was working among these huge transformers, cables, towers, and complex switch gears, and that made me feel like a real engineer. And I learned a lot from that job. When we were instructed to present a topic in our comm class, the first thing came into my mind is I have to do something that is related to my work experience. Here's the outline of my presentation. What is a switchgear? What is inside a switchgear? How does a circuit breaker in a switchgear operate? How many types of switchgears are there? What is GIS? Why some places really need them? So, what is a switchgear? It is a switching device that operates manually or automatically in order to protect and control the power system. What is inside a switchgear? A switchgear has a lot of components in it. For example, circuit breaker, current transformer, potential transformer, relays, fuses, interlocking mechanism, wire discharging mechanism, and other things which depends on the demand of the buyer. Let's see what happens inside a circuit breaker tube or compartment. This is a GIS SF6 circuit breaker compartment, and I have used this video to explain. So inside the circuit breaker compartment, there are two connectors. One is fixed and one is movable, and the compartment is surrounded with an insulating medium. So in normal condition, the connectors are connected and current is flowing through them. But when something has happened, there is a signal coming, and that signal instructs the movable contact to separate from the fixed contact. We can see it here. So when the contacts are separating, a situation called arc is created. See, here's the arc. It looks like thunderstorm. So this arc is very dangerous. It heats up the environment. It can cause fire, flash over, or many other horrible things. So the surrounding medium, here the SF6 gas, its responsibility is to absorb the arc as soon as possible to protect the entire system. So here we can see the SF6 gas has consumed the arc before the complete separation has happened. And based on this insulation medium, there are four types of switchgear. AIS, which means air insulated switchgear. VIS, vacuum insulated switchgear. OIS, oil insulated switchgear. And GIS, which is gas insulated switchgear. And now I would like to say a few things about gas insulated switchgear. Gas insulated switchgear uses SF6 gas as the insulating medium because SF6 has high dielectric constant. We don't need much SF6 gas to extinguish the arc. So the breaker compartment can be made very compact, so the entire unit can be made smaller, doesn't need much maintenance, easy to install, easy to operate, and the best part is you can make a substation in a room by using GIS switchgear. The drawback is it's very, very expensive. I mean, compared to other types of switchgear. In my workplace, I mostly dealt with GIS because I came from Dhaka, which is a small area with large population, and the demands are increasing every day. We need to make more substation, but we don't have much area. So either we are going underground or maybe at the first floor or second floor of a multi-story building. For safety of the people there, we need to use something that is safer than other options. So GIS was the best option for us, and also we don't have much skilled workers to maintain this. Maintain the environment and maintain safety. So GIS was best for us in every way. So most of our newest substations are GIS, and the older ones are now renovated. And the older in older substations, the older switchgears are replaced by the GIS switchgears. So as a part of learning process, I was sent to different companies to learn about the equipment. And the best thing happened to me is that I was sent to a GIS manufacturing company in Malaysia, which is called Tamco. There I worked in the production floor. I saw the raw materials. I saw how they build the product. I saw how they test those products. I had hands-on training how to operate the switchgears from the engineers there. And at the same time, I had a fun trip, got some good amount of money. So every way it was a dream come true experience for me. In fact, one of the best experiences in my life. And I want to join a workforce. I mean, after graduation, I want to join somewhere where I can have this kind of experiences again. And I would really love you guys to have this kind of experience. And I look forward to work with some of you people as my colleague after graduation. And for those who are going for power, I would like to say one thing: power is power. So go for it. If you have any question, you can send me an email. My email address is here. This is my email address. This is a fun trip photo. So, and I have added the link of some sources, and it's you can take a look if you want to know more. Thank you so much for your time. Have a good day.